Good afternoon, everybody. We're here again with the Induron podcast, and we're going to have a conversation about Novasafe. Today, we're going to be having a conversation about a project we recently finished up in Tuscaloosa, Alabama, where we did 2 complete digester lid renovations on new fabricated digesters that are going to be used at the Hilliard-Fletcher Water Reclamation Facility. We're going to have a conversation about the products that we used, why we chose those, and as we've brought in our senior chemist today, we're going to allow her to explain what that product does, its properties, and why it was chosen to be used in such a high exposure to H2S gas and all the other issues that come from wastewater. So sitting with us today is Yvette. She's our senior chemist here and part of the team that created the product that we just finished using. And we're going to kind of bring her into the conversation and let her enlighten us on how we went about creating this product.
Thanks, Nick. So this is actually a really interesting product to work on. I would say it was kind of a fun thing for us to do because at the time of this product's inception, there was a past version that some of our lab that had since retired started with. And then when Chase and I were brought in, we kind of had a new team of people working on it. So I guess what's interesting to know first is that we had some initial good chemical resistance. But let's talk just a touch about the environment.
Right.
So we all know like sulfuric acid, nasty stuff. It's going to kill things. So how do we get more performance out of that? That was kind of the end goal of how do we have something with good chemical resistance that can compete with incumbent systems. So currently there are things on the market called polyaspartics. If you're familiar with them, it's a 2-component, similar to an epoxy. But where you get why they're used in the digester areas is that they're very easy to apply at a high millage. Is that fair
absolutely.
To say, Nick?
Yes, it is.
Yeah. Easy to use, easy to apply, quick cure. But they don't have great chemical resistance.
Right.
So that was kind of the driving factor behind this development. So once we decided we had to go back to the board and rethink a little bit how we could improve our chemical resistance, that's how Novasafe came up. We have this property called cross-link density, okay?
Mm-hmm.
So I want you to imagine like the A side of your epoxy and the B side, your amine. When they get together and start curing, you have these little networks that start forming, and it almost makes think of a lattice.
Yes.
And this lattice is what's blocking the sulfuric acid out. Does that
absolutely
make sense? So what you're looking at in those situations is sometimes doing things on our end, like we get more involved with thinking about functional groups, that kind of real egghead sciencey stuff, but that's in a gist how it works. So with this particular one, we're looking at some really stringent conditions, and we had to go back and kind of look at our additive packages as well as our base amine and epoxy components. So without giving away anything proprietary, that's kind of the gist of how we increase our chemical resistance.
When we're using those in the wastewater settings, like when you were talking about the sulfuric acid kind of leaching of that. So we're talking about wastewater, right? We're talking about human wastewater. Affluent, yes, affluent. Or poop water, right? There's the way we call it, yeah. And tell me why, when you talked about the resin package, why that creates such better resistance compared to just a standard, let's say an NSF epoxy that we use in some of our other areas. Why is this one differentiated? And kind of tell us chemically why and how that happens.
Sure. So something interesting we did without sharing too much stuff is that you have these things on epoxies and 2-component products called functional groups. So let's say you're an amine and I'm an epoxy. Can you stick your hand up?
Yep.
We want our functional groups to attach.
Correct.
Okay. So to get better chemical resistance, one way you can do that is by using something with a higher functionality. So is it stronger if you and I hold hands this way or if we have two groups, this is fine.
Right. Okay.
We're
Right.
stronger.
Right.
So think of functional groups that way. You can add additional ones to give you more sites to latch onto. More sites to latch onto, stronger impenetrable network, therefore better chemical resistance.
Totally get it.
Did you want to share with everyone just any other conditions in these? Like, is there anything besides sulfuric acid that is also breaking down? Like, what are the conditions?
So we're talking just water infused with, I don't even know what the chemicals are called, honestly, that they use to break down the stuff there. And I'm looking off because I don't know how to go with that. Because the way the digester lids are is it's a dome over existing water, affluent water that's being introduced into this tank, concrete tank, being moved. So we're creating abrasion. We're moving everything around in a circle, and all that stuff is being digested out as they're introducing the chemicals in the wastewater environment, and then that stuff evaporates out through the roof. So as these were open top digesters for a long time, now when they decided through some of the new regulations that have come in is that we need to put a lid on these things, literally. So we had to create a steel lid to be dropped into an existing digester. So all of that is expanding and evaporating out the roof of this digester.
So you're at wastewater sites more often than I am.
Yeah.
So this is just a question. Do those domes almost kind of act like they're trapping those gases
Yeah, a little bit.
And
Yes.
Okay, so they do accelerate the corrosion?
Yes, it does.
Okay.
Massively, the corrosion is accelerated because we've now domed and covered that. So, yeah, so we're enclosing all of that to where it had just been kind of evaporating out into the atmosphere, and now we're controlling it by putting the dome on the top of it. So the exterior of this project we treated the outside of this the same way we do as any other steel substrate, right? So we did an SSPC SP6. Actually, we did an SP10 blast on the outside. We primed it
Is that
with
near white metal?
Yeah, that's a
That's
near
the
white
near
metal
white.
blast. Yeah,
Okay.
so that's the
Thank you.
SP10. Yeah, and we did 2 coats of PE70 as a primer and an intermediate on the inside and the outside. So we had like 12 and a half total mils on the outside. When we do a water tank, a lot of times I will specify kind of 8 to 10. We added a little bit more of this, even though we're treating the outside basically just with UV resistance and like weathering like we normally do. But we wanted to stay with a consistent system, so we primed the in and the out both with PE70, our 70% solids NSF approved epoxy, our standard epoxy. That was applied in 2 separate coats. We didn't do it in one big lift. Okay, so we did it in 2 different coats, and then we finished with black Endurethane 6600 acrylic polyurethane.
Good
so we
choice.
were 3.5 to 5 mils on that, and you know that because you helped create that product too. It's just mainly because of the UV resistance, and then it needs to be aesthetically pleasing to some point. Like we aren't
Agreed.
going to leave the outside in an epoxy resin because it'll chalk and fade. We know that. So we just finished it the same way we do like with a tank or anything else that's going to be exposed to the sun. In doing that, we allowed the contractor a little ease of access because they got to use one primer for both. And
that's fantastic.
and we know the robustness of P70. It is a long existing product that we've had in our product line that we've used in many different ways over many different times.
I like how, me personally, I like the ease of use of that.
Big time.
So I'm not an advanced sprayer.
Sure.
Like a lot of your contractors are. So maybe I noticed that a little differently, but that one does have a great ease of use. Just curious, what color did y'all go with?
We ended up tan. So we did a tan and then we striped with white so that we could see the differentiation between the two. But you're exactly right. So the industry is starting to really kind of pick up on PE70 that we have had for a long time for those reasons. It's ease of use, easeability, its application properties are kind of off the chart once we get it into a contractor's hands. It's a thin film epoxy that they're very comfortable with.
So what if I wanted to go with something, I'm just curious, because we do a lot with ceramic epoxy. Would that be a choice like Ceramiprime even at some point? Or
Yeah,
has
it absolutely.
70 worked with the Novasafe as well?
We chose PE70 just because, specifically on this job, I had kind of an option of both.
Okay.
And the contractor was a little more, I don't want to say he's comfortable with the other. He was had a longer history of working with PE70.
That's fair.
So
We've all
I had-
got preferences.
Yeah, I had
when I go
options.
buy makeup at Sephora,
Yeah, that's
I
right.
got preferences.
So
I get it.
the engineer wanted a minimum of 40 mils on the entire project, which we can achieve with Novasafe, right? We can go up to 40 mils wet, and we can go up more than 40 mils wet, but we can end up with a 40 mil dry film system. But by inducing those 2 coats of primer, it was going to make it easier on the contractor that he could do 30, and it would make it easier on him in his application of this instead of trying to do all of it in one lift again.
Okay.
Plus, this is something that we really incorporated in our tank world. The human side of this is that we're making these guys touch this thing 3 times, actually 4 times when you do a stripe coat. So you blast and you go coat of primer, another coat of primer,
That's your stripe.
and then another primer, and then another coat of primer, PE70. So 2 is called a first and intermediate, and then a stripe coat where we stripe all the seams, the welds, the voids, any sharp area, anything that we consider high failure rate on those areas. And then we come back with the Novasafe at 30 to 35. So we've got a complete 40 to 45 mil system once it all gets put in place. And the robustness, which is what I want you to tell us.
The robustness.
Like I want to lead you into that with the Novasafe and why we use that there.
Sure.
And it's similarities, but not same to some of the other products in our line.
I would say with Novasafe, kind of think of it as if you're familiar with a lot of our NSF products like PC100 or PE70.
Yes.
Any of those. I would say imagine this, but it's stronger older brother.
Yeah.
So Novasafe can go in a bit more stringent environments sometimes than a traditional NSF water, potable water tank lining, but it's got some extra added properties. So I would say one of the things we can highlight here is that it is in fact a ceramic epoxy, which is a technology that, Induron really prides ourselves on, and it's been proven to work. So it has that advantage, the, better cross-link density, therefore better acid resistance factor going on, and it also has good abrasion resistance.
So tell me, like I'm a paint guy, but I'm a field paint guy. So why, right? Tell me kind of chemically what you put into that or what we made that gives us that abrasion resistance and gives us that more, even get as detailed as like some of this, I guess, I don't know what our resins are in that. Like teach me about it.
Yeah. Okay. So, I mean, in general, let's think about what are the basic ingredients of paint and why does it need to be there? So the main ingredient doing the majority of the work on that is going to be your resin and curing agent. So your epoxy resin and your typically some type of amine functional curing agent.
Okay.
I say typical because there's different types out there. So those are really doing the base of your work. They're doing the heavy lifting. Almost think of them as like the bottom layer of the pyramid.
Gotcha.
And then think of your additives as like the top.
Yep.
We don't add as much. Those are like little pinches. Think of them more like seasoning.
Yeah.
You're not going to put a whole lot of celery salt or Texas Pete or anything, right?
Right.
So just a little sprinkle, a little dab will do you. But in addition to that, the filler package has some unique properties. So we put some things in there that are a little bit more, let's say, chemically inert, without telling you exactly what's in it.
Absolutely.
We changed a few things in the filler package to make it more robust as well as the additives. So there are different types of additives, pigments. Something that might be interesting for our listeners is that what type of corrosion inhibitor or additive you put in depends on the layer of where it is in the process.
Yeah. Okay. So explain that. Yeah.
Okay. So
and the reason why I want to get into this too is a lot of times we just hear paint.
yeah.
And it's like, man, it's paint, and then it's just been my career for 24 years, but there's so much more that goes into this. And the technology that we use and that we get to put into these products is we really are kind of forward thinking and really forefront in the industry. And we like to say that Induron is way out front in the way that we push and use our technology. And these kind of settings give us an opportunity for you to kind of expand on that. Because I'm just a sales guy. So I understand what that is. And when I'm educating people in the field on these things, I use a lot of the same stuff, but I will talk about cross-linking or layers or density or dry film thickness. But it is so cool to kind of get to hear man, someone who makes the cake, as we talk about,
Yes.
right, and the ingredients of it and the way and the process that you guys came up with, all of the things that go into this black paint is what you ultimately end up seeing. And a lot of times we just look at it as though it's a black paint, but there's so much that goes into this
Yes.
and the technology. So that's kind of why I'm asking this.
You know, Nick, I'm glad that you asked that about just how can we, what are we doing to the formula that makes it kind of unique or makes it special maybe from, or what differentiates it from other products, either from us or, you know, out in the market. So we talked about kind of how you have that triangle base, like think of your resin and curing agent doing the base of the work, your filler package, and then your additives. So I think we should start and maybe get into that a bit more. Just what do you think?
Well, we can, but since we've got kind of a natural break, if we want to kind of bring Chase in, who's
Yes.
our technical director of the whole building. So
Okay,
we have an
great.
opportunity to bring Chase in and let him kind of talk and get involved in this conversation. So thank you. That was
welcome.
awesome. I always personally enjoy getting to talk to you guys, which is why I stick my head in the lab all the time, because we're the people in the field and I'm like, I need bullets for the guns here. So I come ask you guys. But thank you. That was perfect.
Thanks, Nick.
And we're going to get Chase involved. So now we're going to bring in Chase Murphy, who is Induron's technical director, and we're going to continue talking about Novasafe, and we'll get him to kind of educate us more deeply on the product, how we made it, why we made it, and what makes it different.
Yep. Yeah, Novasafe was a great project for the lab because we were able to really start from the drawing board with that, because it wasn't a modification of an existing product. It was kind of built from the ground up.
Yeah, you guys got a chance to really start this from scratch, didn't you?
Right. Yeah. So, I mean, I started this on an Excel spreadsheet. It's brand new, no limits. So I was able to start with one of the highest quality Novalac resins for the epoxy side. And then we were free to use the newest generation of curing agents on the amine side as a crosslinker. So we literally just started with the math on an Excel spreadsheet, optimize the ratio, make sure the math worked out for our cross-linking functionalities.
Yeah.
And then we went from there, and we really designed this product using a one factor at a time approach, which means I basically started mixing the resins together, curing up pucks of just the resin, no pigments, nothing else in it, and seeing how those performed in the most severe chemical, which would be sulfuric acid.
Right.
And once I got the optimum properties out of that, we knew kind of what fillers we wanted to use. So we'd introduce one at a time to that resin mix, expose it to sulfuric acid. That way we're able to see where failures occur, and we're able to tell what do we want in the product and what do we want not in the product, to kind of optimize our chemical resistance.
From my end, so I've worked at a couple different places. That, to me, this is one of the things that separates us and is really sweet about Induron, is we're actually talking to the technical director, the guy that kind of created the product. So we will come up with a need in the field. So we saw that we had kind of a gap and we needed this product at the top of our product kind of offerings. So we came back and started creating, I know Bill Sewell and me and a couple other guys in the field were like, man, we really need kind of that thick film system, like right at the top of all of the exposure level product. And here, the way we do that is we walk in and have a conversation. So we talk to Chase, we talk to Davies, we think we have a need for a product, and then we start asking questions, and then these guys create it chemically from scratch. And our ability to touch you guys, talk to you guys, and watch that process is super cool. Like, especially from the sales side. From the guy in the field that's going to go take that out to the market. For us to be able to see along this, it was like a year and a half, right? Or 2 year process.
Something like that.
Yeah, that we had to make that product, is that we would be given feedback. Hey, Chase is at this point, or Chase is at that point. And then we know, like in real time, we're going to get that product, and then really what it's going to do. That is so different in the market and we're existing of like coatings manufacturers, is that we get to have a conversation with them first of all and know what they're making based off of kind of the requests that we have. I'm just seriously think that's pretty cool because I know I stick my head in there a lot and ask you guys questions, but to get to see you come across that process and then see all of the different versions and like as you change it and move it, that's really kind of neat.
Right.
So how long does that process take? I mentioned it, but kind of reality, like tell me how long it takes to get there.
Yeah, it can take a while sometimes. With this one, we had to do a lot of chemical immersion testing, which, how long do you go to be comfortable with the product? We use higher temperatures than you'd normally see in the field to kind of do a more severe test and accelerate the process. But that kind of chemical exposure testing, a year maybe, is acceptable.
Do we do all that here? Right, we do that in-house?
Right, we do it in-house.
Okay. How? So how do you do that? What is that testing?
Literally, you have the panels that are the same substrate that customers will be coating in the field. Mm-hmm. You spray those up with your system, and then you prepare quart-sized jars of the chemicals they're going to be exposed to, and you stick them in, and you wait.
So that's what all those jars are that we've got. Okay, that's awesome. So we physically have samples of this product through its process of kind of being created, immersed underwater in different levels of chemical exposure, right? Yeah, okay.
Right.
And that's how we physically do the testing. So instead of like guessing, we do the physical testing to each of the properties and all these different chemical exposures.
Yeah, that's correct.
Okay.
Yep. And once you're at a place where you're comfortable with the chemical resistance testing, you kind of move on to the application where, okay, let's scale this up to 5 gallons and actually put it in an airless pump and spray it and see how it applies. Because that's really one of the more important things is you can get a great lab animal.
And it has to perform.
That seems perfect, but if you can't spray it in the field, it's worthless. Then
at that part on my end, it's not going to get any run. So that's neat. I was wanting to go into that is like when you get to that process, we physically test the things here. And we do, right? So we've got a spray booth and things, and we've got every pump known to man, and we will all come in kind of as a group. After Chase has done all of his playing with it, we'll break that product out and like physically get our hands in it and spray it. But that these guys have to think like throughout that whole process of not just making the product that's the very best for the chemicals it's going to be exposed to, but we're going to put this in an applicator's hands. Like we're going to put this in a painter's hands, and it has to work in his world. And we all understand that the lab is different from outside. Mm-hmm. And in the field, like those are the feedbacks that I get, like, hey man, I'm going to be painting at 35 degrees and 50 degrees and 70 degrees. And so we go through that process here. Like we will test all of those different faculties before we get to a finished product.
Yeah, sure. As reasonably can, with different temperatures, it kind of depends on the weather outside.
That's right. Yeah.
But yeah, we're just out there spraying 4x4 panels, making sure we get a good film.
Yep.
Making sure everything works. Do we get a lot of tip clogs? Is the viscosity right to flow through the hose and make it out onto a panel and something that looks relatively good aesthetically?
And all of that is so important because I guess that's where the magic happens kind of in the field is that product has to do kind of what we say it's going to do and apply the way that the mouths of us, which is me, right, or some of our other guys, as we're all talking about it, is we're getting the information from Chase. So we're truly talking about like the father of the product here. I can't kind of elaborate on that enough of how important that is. It's not a technical data sheet that's been shoved down to a group of guys that are told to go put this in the market. We have requested this, and we make it here. We can talk to the chemist and we can have that conversation with you guys and you educate on us before we go out and start ever talking to anybody about it. So that's why I was so confident when we get into this project as we kind of launched it out. I was like, man, we got all of this that's already been done. Chase has sprayed the product. We've all sprayed the product. We know what it's going to do. And then when we take it to market, man, it is really ready for show. So for you to be able to just kind of off the cuff here, sit here and just spit that information out to me. As I always talk about y'all, the smartest guys in the room, and I like it to get you to kind of be exposed to this and let us all hear about it. it just differentiates us. And I say that over and over again, but it really does.
Right.
So anything else to that product? Like, how do you have any kind of issues making it? I mean, what did you run into? Like, what was the hard parts? What was the easy parts?
I think the hardest part was there's some preconceptions about what a highly resistant acid formula should look like. And like I mentioned earlier, we went through the one factor at a time testing, and we were like, whoa, some of this tribal knowledge might not be true.
Yeah.
Let's go back and reevaluate. And we did, and we were kind of able to implement some, novel chemistry into the product to get us past those hurdles.
How many of you guys are there over there in the lab? I know, but how many? You tell the people how many guys we have working on this, or ladies and guys?
We got 4 people in R&D.
Yep.
And then we've got a kind of a additional R&D person with our QC manager, who's got a lot of knowledge that we go to a lot. But it's me, as technical director, and then as the chemist, we have Trevor Nicholas, Yvette Box, and Desiree Eason.
Yep.
And then Steve Schnell in QC.
Yep. So we've got processes, man. We've got all these different guys involved and ladies involved that kind of get us to the end unit for this. And the 2 buckets that are kind of sitting here in front of us, it's funny. And even for me and my applicators that we talk to, it's paint. I said that to begin this on a reason, and it's not. Right. So these are just massive different groups of chemicals that come together. And especially in our world, because everything we work in is 2-component products, from our polyurethanes to our epoxies to our Novalac resins, which is just another version of an epoxy. And that we get to see all of that from the beginning. And then that when it gets into paint in a bucket, we're teaching them how to use it. And that's it's pretty neat that we get to see it from the beginning to the red bucket. Chase? Man, thank you so much for coming on and talking to us and educating me and everybody else about what it took to make this product and all of its different properties.
Yeah, no problem. I learned just as much from you every time we talk, so it's great.
Thank you. It was great. Thank you guys for tuning in and listening to this version of our Induron podcast. We hope to see you next time.